Good afternoon, all. My name is Prachi Vanhavan. I am as assistant professor in EX department, SIRT Bhopal. Today, we will discuss about the Unit 2 in BEEE, Basic Electrical and Electronic Engineering. Our second unit is AC circuits. So now, first of all, we will discuss about what is a use of AC. So up till now, we have discussed about DC supply and DC circuits, but 90% of electrical energy used nowadays is AC in nature. Electrical supply used for commercial purpose in alternating. The DC supply has constant magnitude with respect to time. Such changes in magnitude and direction is measured in terms of cycle. Each cycle of a AC consists of two half cycle, namely a positive cycle and a negative cycle. So this unit explain analysis of AC circuit and their operation. Use of capacitance transducer. After completing this unit, you should be able to analyze passive AC circuits comprising resistors, inductors, and capacitor to determine current flow, voltage distribution, and power dissipation. Identify series resonance, analysis power factor, improvement circuit. Describe the operation of capacitance transducer and their use in measuring displacement. So now move to the we have introduction about AC circuit. What is a AC waveform? Electricity supply the system are normally AC alternating current. The supply voltage varies sinusoidal, instantaneous applied voltage. Here is a AC sinusoidal waveform. So now here starting from zero. So this is a here this is a peak value and amplitude. So highest value is called a peak value. Vm it is denoted by Vm. Vm is a peak applied voltage in volts. So 0 to pi and pi to 2 pi. This is called 0 to 2 pi is a time period. Full time period is a T. And uh, here is a frequency F, supply frequency in hertz, in T time in a second. This is an introduction about AC alternating current waveform. Now move to the next slide. Move to the next slide. Resistance connected to an AC supply. So when we connected in resistant and AC supply, here we see that this is a AC source. Here we denote by V is equal to Vm sine 2 pi f t. So here f is a frequency. We can write f is equal to omega t. So we can write here in f replace f by omega T. Okay, now this is a load. Here we connected in a resistance. So instantaneous current is I is equal to V by R. So V is equal to, we see that V is equal to Vm sine 2 pi ft. So we replace V is equal to Vm sine 2 pi ft upon R, and I is equal to Im sine 2 pi ft. So here is a phasor diagram. This is showing phasor diagram. V and I is a same phase. So phase difference V and I is 0. So we see that when phase difference is 0, so V and I is a same phase. Here this is a voltage waveform and this is a current waveform. Voltage waveform is a V lead the V is a voltage waveform and I is a current waveform. These are the same phase. That's why here is a phase difference is a 0. Thank you.